The last light of day lingers on the horizon as the sun slowly sinks out of sight. The sky is painted with gentle hues of orange, pink, and purple, blending into the deepening blue above. A calm hush falls over the landscape at dusk. Far-off clouds catch the sun's departing rays, glowing in soft rose and gold before fading to grey. Distant hills and trees stand as dark silhouettes against the colourful sky, as if nature itself has paused to admire the sunset. Warm daylight ebbs away, and a cool breeze begins to stir, carrying the subtle sense of nightfall. Shadows stretch long, and then disappear into the growing dusk as Earth turns away from the sun, welcoming the quiet embrace of night. In this tranquil twilight, the world seems to hold its breath. The air cools steadily as daylight slips away. Birds offer a few final chirps before settling in their nests, and day's last glow gently yields to dimness. Overhead, the first stars timidly appear, tiny pinpricks of light against a sky that deepens from blue to indigo. For a moment, they are faint and few, as if testing the darkness. But with each passing minute, as the heavens grow darker, more stars awaken and sprinkle across the expanse above. Night's approach brings a subtle change in the living world. The breeze carries new sounds now. The gentle chorus of crickets hidden in the grass, beginning their nightly song. A frog voices a slow croak from a distant pond, and perhaps an owl hoots softly from a darkened tree. Diurnal creatures have taken shelter and fallen quiet, ceding the hours to those that thrive after dusk. Overhead, a bat flits in silence, chasing insects through the cooling air. It is a peaceful transition, day's energetic hustle fading into the quiet, rhythmic pulse of night. The hush feels comforting, as if the earth is tucking itself in under the blanket of darkness. A brilliant evening star emerges near the horizon, perhaps the planet Venus, shining with a steady silver light. If the moon is in the sky tonight, its slender crescent hangs low and delicate, adding a gentle glow to the twilight. The western sky still holds a faint amber afterglow of sunset, a memory of the day that was, while above, night's kingdom slowly takes hold. With every passing minute, new stars come into view, as if someone were lighting one lamp after another in a vast, dark hall. Far from the glare of human lights, the darkness deepens to reveal an ancient spectacle. The sky overhead turns a richer blue, then indigo, then finally a profound black. In that darkness, a multitude of stars come into sharp relief. Each new point of light seems to bring the night more alive. Where once only a handful of stars were visible, now there are too many to count. A glittering swarm across the sky. The air has grown cooler, and the noises of daytime have given way to a peaceful silence, broken only by the occasional trill of a night insect or the rustle of a breeze through the grass. It is as if the earth itself is exhaling, relaxing under a blanket of stars. For countless generations, people on earth have watched this same transformation from day to night with wonder. As the familiar world of daylight fades, a different world emerges overhead. There is a special calm and reflection that comes with nightfall, a gentle reminder of our place beneath the infinite sky. Think of our ancestors ages ago, gazing up at these same stars. Ancient farmers, sailors, and travellers looked to this canopy for guidance and inspiration. The tiny lights above have guided caravans across deserts and ships across oceans, and have inspired myths and prayers around lonely campfires. Under this celestial dome, separated by centuries and cultures, hearts have been comforted by the same silent beauty. Now, as darkness fully settles, we find ourselves under a sky alive with stars, ready to journey deeper into the cosmic night. The night sky above has become a vast tapestry of stars. Thousands of distant suns shimmer quietly, scattered across the dome of night. Some shine bold and clear, while others are tiny and delicate, on the edge of human vision. They carpet the heavens from horizon to horizon, like glittering dust on velvet. The stars seem to twinkle gently, their light reaching us through the thin ocean of air above. Overhead, the canopy of darkness is alive with this subtle, sparkling light, ancient, steady, and serene. As our eyes adjust to the darkness, even more stars emerge from the gloom. A faint haze of light becomes recognizable as countless individual points. Stars that were invisible moments before now gradually reveal themselves, adding depth to the cosmic panorama. The longer we remain under the night sky, the more our vision adapts. After many minutes, where we once saw only dozens of stars, we can now see hundreds, and then thousands. It's as if the longer you gaze, the more the universe opens up to you. We begin to notice that not all stars are quite the same. A keen gaze might catch subtle differences in colour and brightness among them. Most stars look white at first glance, but a few glow with hints of blue, gold, or red. These colours are clues to their nature. Blue-white stars burn fiercely hot and young, whereas orange and red stars are cooler or older. For example, the shoulder of the constellation. Orion is marked by Betelgeuse, a star with a gentle reddish-orange hue, while in contrast, another of Orion's stars, Rigel, shines blue-white. Such variations are delicate to the eye, yet they enrich the sky's beauty. Altogether, they blend into the soft collective glow that dusts the heavens. As we gaze upward, patterns start to form in the stellar scatter. The human imagination connects the dots. Here, a curve of stars suggests a hunter drawing his bow. Over there, a crooked cluster outlines the shape of a great bear. These are the constellations, age-old connect-the-dot figures traced by our ancestors. Every culture has looked at these same stars and envisioned pictures and stories, heroes and monsters, animals and gods, forever outlined in points of light. Under this starry canopy, we are linked with all who have ever looked up in wonder and wove tales about what they saw. Even the smaller gatherings of stars in the sky have inspired legends. Take the Pleiades, a tiny cluster of blue stars that glitters like a miniature dipper high overhead. On a clear night, most people can discern 6 or 7 stars in this cluster with the naked eye. Across the world, many cultures saw those 7 stars as a group of sisters. In Greek mythology, they were the 7 sisters pursued by Orion. In other traditions, they were 7 little girls or 7 divine maidens placed in the heavens. That the same cluster inspired similar stories in distant lands speaks to a shared awe, a connection formed by people separated by oceans, yet united under the same stars. Some stars hold special significance in the sky's grand design. In the northern sky, one star, Polaris, the North Star, sits almost directly above Earth's North Pole, and so it appears nearly motionless, while the rest of the stars slowly wheel around it. Though not the brightest star, its steadfast position has made it a trusted beacon for centuries. Northern travelers and sailors would gauge their direction by Polaris, knowing that it always points the way north. In the far southern skies, a compact cross-shaped constellation serves a similar purpose. The Southern Cross, small but striking, points toward the south pole of the sky. For those below the equator, this pattern has long helped navigators orient themselves on the open sea. These celestial beacons remind us that the stars have not only inspired stories, but have also guided real journeys across the Earth. Over the course of the year, the panorama of stars above us subtly changes. Constellations that dominate the winter evenings will, a few months later, sink toward the west and make way for the stars of spring and summer rising in the east. This is because, as Earth travels around the sun, our night sky faces different depths of space. Each season offers its own starry wonders. The great hunter Orion and his brilliant dog star Sirius Grace, the winter night. The radiant band of the Milky Way and the summer triangle glitter in the warm summer sky. Yet some stars near the celestial poles circle year-round, never setting, eternal sentinels in the sky. The cyclic appearance of the constellations gave our ancestors a calendar in the heavens, marking the passage of time and the turning of the seasons, all while the stars themselves remain unchanged and eternal. So, as the night deepens, the stars begin a slow dance across the sky. Over hours, they drift from east to west, tracing gentle arcs above the horizon. This silent parade is a reflection of Earth's rotation, our planet turning steadily beneath the sky. If you mark a star's position and check again later in the night, you'll find it has shifted, as though the heavens were a grand clockwork. In fact, long exposure photographs of the sky reveal graceful concentric trails, each star leaving a circular path centered around the pole. The slow wheeling of the firmament overhead reminds us tangibly that our Earth is spinning through space, even as we stand still, gazing upward. Now and then, a streak of light silently pierces the darkness. A shooting star. These meteors appear without warning, usually just a tiny grain of cosmic dust, burning up as it plummets through Earth's upper atmosphere. For a brief moment, it etches a thin, glowing line across the sky, then vanishes forever. Often they're gone before we fully register their presence. Yet for that flash of time, they can startle and delight us. One might appear at the corner of your vision and cause you to gasp softly at its suddenness. Many people carry the tradition of making a wish when they see a falling star, adding a hopeful human dream to that tiny celestial spark. At certain times of the year, the sky offers an even greater spectacle. When Earth passes through the dusty trails of comets, meteor showers occur, and dozens of these shooting stars may streak by in the space of an hour. In August, for instance, the Perseid meteor shower can sprinkle the sky with a gentle rain of cosmic light. Each meteor is a reminder of the ceaseless activity in the cosmos. Even on a night that feels still and quiet, under the dark vault of the sky, these brief darts of light deepen our appreciation of the ever-changing nature of the universe above. Every point of light in the night sky carries a story across time. The glow from these stars set out ages ago, years, centuries, even millennia before it reaches our eyes. When we look at a distant star, we are witnessing a memory, light that left its source long before this moment, travelling trillions upon trillions of miles to arrive here tonight. Some of the brighter stars we see may be relatively nearby, their light only a few years old. Others are far more distant. The star Deneb, for instance, is so remote that the light arriving now left that star roughly 26 centuries ago, during the time of ancient empires and philosophers. In this way, the night sky is a kind of time machine, allowing us to gaze into the deep past from the present. Under the stars, we are gently reminded how vast time and space truly are, and how patient the universe is in sending its messages of light. Indeed, there are stars visible tonight that no longer exist as we see them now. A star's life can be millions or billions of years long, but even stars eventually exhaust their fuel. Some may have lived out their lives and faded into dim embers, or ended in spectacular explosions. Yet we still see their light because it left those stars long ago and is only now reaching us. In this way, the heavens hold echoes of the past, a cosmic record written in starlight. It is a humbling thought. Even the stars are not eternal. They too are born, shine for eons, and pass away. But their light endures for a while beyond them, travelling through space so that we may witness a glimmer of stars that have already vanished into darkness. Though they appear as tiny pinpoints, each star is a sun in its own right. Many just as mighty as our sun, and some far more powerful. Modern astronomy has revealed that most of those stars likely have planets of their own, circling around them as our Earth orbits the Sun. We cannot see those distant worlds with our eyes, but we can imagine them. Perhaps under alien skies, other moons are shining, and other beings might be gazing up from their own landscapes. Under the starry sky, we cannot help but wonder, is there life out there in the vastness, on some planet orbiting one of those distant suns? Maybe far across the cosmic gulf, on a night in some other world, there are eyes turned toward the stars, eyes that might even glimpse our sun as just another star in their sky. Such musings make the universe feel both enormous and intimate. In the grand solitude of space, we sense the possibility that we are not entirely alone, even though for now the silence between the stars remains unbroken. Looking higher now, on a clear, moonless night, you may notice a pale, gauzy band of light stretching across the sky from one horizon to the other. At first glance, it might appear as a wispy cloud or a trail of smoke frozen in the darkness. But this is no ordinary cloud. It doesn't drift or change shape like clouds do. This ghostly river of light is the combined glow of uncountable distant stars, too far and faint to see individually. It is the Milky Way, our home galaxy seen from within. It arches overhead like a luminous pathway through the night, a bridge of starlight crossing the sky. Under a truly dark sky, it becomes unmistakable. A broad, milky band with subtle patterns of light and dark, beckoning us to ponder the immense structure that cradles not only our star, but billions of others. For countless years, the true nature of the Milky Way remained a mystery. To the naked eye, it is just a diffuse, milky white pathway overhead, hence the name Milky Way. People in ancient times saw this soft glowing band and crafted stories to explain it. In Greek mythology, it was said to be the milk of the goddess Hera sprayed across the heavens. In other cultures, it was seen as a road, a path for wandering spirits, or a bridge connecting Earth to the realm of the gods. To many, it was simply known as the Sky River. Around the world, This band of light earned different names, but inspired the same awe. In China, it has long been called the Silver River, and in India, one poetic name for it is the Ganges of the sky. In parts of southern Africa, the first peoples spoke of it as the backbone of night, as if the stars were the glowing embers that held up the sky's darkness. Each name captures a sense of wonder and imagination. Under these stars, people everywhere felt the Milky Way was something sacred or significant, a bright ribbon binding earth and sky, night after night. Today, we understand what the Milky Way truly is. That faint band is the collective glow of billions of distant stars. We are looking edge-on at the disk of our own galaxy, seeing its densely packed stars all blending together from our vantage point inside it. Our Milky Way is a spiral galaxy, a vast, flattened system of stars, gas, and dust, shaped somewhat like a giant whirlpool. Our Sun is one of those many stars, orbiting within this enormous city of stars. From our perspective on Earth, inside the galactic disk, we perceive the bulk of our galaxy as that milky arch across the sky. It was only a few hundred years ago that we found solid evidence of the Milky Way's true composition. In 1609, the Italian astronomer Galileo Galilei pointed one of the first telescopes at that luminous band and discovered that it was made up of countless faint stars. What had appeared to the unaided eye as a cloudy glow was revealed to be a multitude of far-off suns packed together. This was a stunning revelation for its time. Since then, our tools and understanding have grown, and we have mapped the structure of our galaxy in detail. Yet even now, stepping outside on a dark night to see the Milky Way with our own eyes can evoke the same sense of wonder that Galileo must have felt peering through his little telescope. The Milky Way galaxy is almost unfathomably vast. It spans about 100,000 light-years from end to end. To put that in perspective, even a beam of light, the fastest thing we know, racing at 300,000 kilometers per second, would take 100 millennia to travel from one edge of our galaxy to the other. Within this immense disk, astronomers estimate there are several 100 billion stars. Hundreds of billions of suns, each with its own story, all bound together by gravity in this one galaxy. And among them is our Sun, a fairly ordinary star in the galactic mix. The mind reels trying to grasp such scales, distances so huge and numbers of stars so large that our familiar frames of reference fall away. Our solar system resides in the Milky Way's quieter suburbs. We are about 25,000 to 30,000 light-years from the galactic center, positioned within one of the galaxy's spiral arms, a region known as the Orion Arm, which is a smaller offshoot of a larger spiral arm. Being in this location means we have a grand view of the rest of the galaxy spread out around us. When we look toward the constellation Sagittarius on a summer night, we are peering toward the galaxy's bustling center, and the Milky Way's band appears thicker and brighter. In the opposite direction, toward Orion in winter, we look toward the sparse outer regions of our galaxy, and the Milky Way appears fainter. From our vantage point inside the disk, we see the stars concentrated along the plane of the galaxy as a band encircling us. It's as if we are immersed in a great starry ocean, with the densest waves of stars forming that glowing river of light across the sky. Looking closely at the Milky Way's band, you'll notice it's not uniformly bright. There are gaps and dark patches cutting through the glow. These are not empty holes, but clouds of interstellar dust blocking the starlight from behind. Vast cosmic clouds of tiny particles drift between the stars, and where they collect thickly, They form dark, river-like rifts in the Milky Way's light. To the eye, it might seem as if parts of the Milky Way have been erased, or as if a great fissure runs through it. One prominent darkness divides the bright summer Milky Way. Astronomers call this feature the Great Rift. These dusty clouds are the raw material for future stars. They absorb and scatter light, hiding what lies beyond. Yet knowing what they are adds another layer of wonder. Even the darkness we see in the starry band is full of matter and potential. Behind those dusty veils, in the direction of Sagittarius, lies the heart of our galaxy. We cannot see the galactic center with our eyes, because dense dust clouds make it opaque. But scientific instruments reveal a crowded, energetic region there. At the very core resides something extraordinary and hidden. A supermassive black hole, an object with the mass of about 4 million suns packed into a space smaller than our solar system. This dark giant, called Sagittarius A, emits no light of its own, yet its gravity orchestrates the motions of stars near the center, causing them to swing around at astonishing speeds. In a sense, it is the anchor of our galaxy, a massive presence holding the inner Milky Way together. Though invisible directly, we know it's there from its powerful influence, like an unseen conductor guiding a swirling dance of stars. It's humbling to realize that at the center of all the light of the Milky Way lies a profound darkness, a still point around which our entire galaxy rotates. Throughout the Milky Way, new stars are being born, even as old stars perish. Within the galaxy's spiral arms lie vast stellar nurseries, immense clouds of gas and dust that serve as the wombs of stars. Under the pull of gravity, knots within these clouds condense until nuclear fusion ignites and a new star begins to shine. Some of these regions are faintly visible from Earth as hazy patches in the Milky Way. A famous example is the Orion Nebula, located in the sword of the Orion constellation. To the unaided eye, it appears as a small fuzzy spot, but telescopes reveal it as a luminous cloud of gas where dozens of newborn stars are emerging, their light causing the nebula to glow. There are many such nurseries sprinkled throughout our galaxy, hidden within the spiral arms, incubators of the next generation of suns. Just as stars are born, stars also die within this galaxy of ours. Most stars will end quietly, fading over long periods of time. But the most massive ones die in dramatic fashion. They explode as supernovae, unleashing a burst of light and energy. For a brief period, a single star's death throes can outshine all the other stars in its vicinity. Historical records tell of supernovae so bright they were visible on Earth even in daylight, startling those who witnessed a new star appear in the sky. After the brilliance fades, what remains might be a tiny, ultra-dense core, or perhaps a black hole, surrounded by an expanding cloud of debris enriched with heavy elements. Smaller stars, on the other hand, gently shed their outer layers as they near their end, creating beautiful, glowing shells of gas called planetary nebulae, cosmic smoke rings that slowly dissipate into space. These life and death cycles have been unfolding for billions of years, generation upon generation of stars, lighting up the galaxy and eventually dimming, like cosmic fireworks playing out on timescales unimaginable to us. Incredibly, these stellar life cycles are intimately connected to us. When massive stars explode as supernovae, they scatter the elements they forged in their hot cores far across space. The carbon in your cells, the calcium in your bones, the iron in your blood. These atoms were created in the nuclear furnaces of stars, or in the titanic explosions that marked their deaths. Those elements drifted through the galaxy in great clouds, mixing and coalescing, eventually forming new stars and new planets. Our Sun and our Earth were born from such a cloud of cosmic remnants roughly 4.6 billion years ago. We literally carry the ashes of ancient stars within our own bodies. Knowing this can transform the way we see the night. When we stand under the Milky Way's glow, we are not just observers of the universe, we are part of it. The universe gave birth to the ingredients of life and consciousness within us. In a very real sense, we are a way for the cosmos to know itself, star stuff that has awakened and is now gazing back at the stars. From our vantage point on Earth, we see only a slice of our galaxy's grandeur. If we could leave our planet and rise high above the Milky Way, we would behold a breathtaking sight. A gigantic spiral floating in space, with curved arms of stars coiling around a bright core. We'd see that our Milky Way has a barred center with spiral arms emanating from the ends of the bar, filled with countless stars and nebulae. From that perspective, our entire solar system would be just an invisible speck in one of those arms. All the stars we see on a clear night, those thousands of points, occupy just a small patch of this galactic disk. Yet from within, on Earth, the edge-on view of this spiral presents itself as the Milky Way band. Even without leaving the ground, we can sense the majesty of the structure we live in. Standing under the arch of the Milky Way, we can appreciate that we live inside a massive, spinning galaxy, a tiny part of an enormous cosmic home. For a long time, the Milky Way was thought to be the entire universe. Generations of people assumed that hazy band of light and the stars around us were all that existed. And for an observer with the naked eye alone, nothing beyond was obvious. But early astronomers with telescopes noticed faint, cloud-like patches in the night sky that did not belong to the Milky Way. These were called nebulae, and their true nature was uncertain. It wasn't until the early 20th century that we discovered the staggering truth. The Milky Way is only one galaxy among countless others. In 1924, Edwin Hubble measured the distance to one of these faint patches, the Andromeda Nebula, and found it to be far, far outside our own galaxy. It was a galaxy in its own right, as large as the Milky Way and millions of light years away. This discovery expanded our understanding of the cosmos immensely. The universe suddenly grew in our minds from one galaxy to a multitude of galaxies, like discovering that what we thought was the entire ocean was just one island surrounded by a vast sea. On an exceptionally dark night, far from any city lights, it is possible to see one of those other galaxies with the unaided eye. In the constellation Andromeda, a faint, oval smudge of light can be discerned if you know where to look. The Andromeda Galaxy. To our eyes, it's just a tiny, misty cloud hanging in the sky. But in reality, it is a colossal spiral galaxy, much like our own Milky Way. It contains on the order of 1 trillion stars. Its pale light has been traveling through space for 2.5 million years to reach Earth. When you gaze at Andromeda, you are looking across an almost unimaginable gulf of space and time. The photons hitting your eye left that galaxy long before modern humans existed. In fact, they were already on their way toward us when early human ancestors first learned to make simple tools. If you think about it, you are seeing Andromeda as it was in the distant past. And in a subtle way, Andromeda is intertwined with our future as well. Our two galaxies are drifting toward each other, and billions of years from now, they will merge into a new, larger galaxy. But for tonight, Andromeda remains a tranquil, distant lantern in the darkness, a gently glowing symbol of the wider universe beyond our home. In the southern hemisphere, the night sky offers a different glimpse of our galactic neighborhood. There, one can see two faint, cloud-like patches of light hovering apart from the Milky Way's band. These are the large and small Magellanic Clouds, two dwarf galaxies that orbit our Milky Way. To the unaided eye, they look like detached pieces of the Milky Way, or wisps of milky fog. Early sailors, like Magellan's crew in the 16th century, used them as reference points in navigation, hence their name. Though much smaller than the Milky Way, they still contain billions of stars each. They are our galaxy's companions, bound to it by gravity. When you see the Magellanic Clouds, you are witnessing our galaxy's immediate family, shimmering quietly alongside the Southern Cross and other southern constellations. It's a poignant reminder that even our giant galaxy travels through the universe with a small entourage of galactic kin. Our Milky Way and Andromeda are the two giant members of a gathering of galaxies known as the Local Group. This group is our cosmic neighborhood, a collection of about 50 galaxies of varying sizes, bound together by their mutual gravity. Most of the members are much smaller dwarf galaxies, many of them satellites orbiting the Big Two. The Magellanic Clouds are among these. The entire Local Group spans a region about 10 million light-years across. All its galaxies, including our Milky Way, move in orbit around a common center of gravity, like a loose swarm of bees. And the Local Group is not alone. It is part of an even larger assembly called the Virgo Cluster. The Virgo Cluster, centered about 50 million light-years away, contains thousands of galaxies in a massive cluster that dwarfs our Local Group. Under powerful telescopes, the heart of the Virgo Cluster reveals galaxies scattered like a swarm of glittering fireflies against the void. And beyond that, we find that galaxy clusters themselves bunched together into colossal superclusters. These structures form a pattern akin to a cosmic web. Filaments of galaxies stretching across hundreds of millions of light-years, with vast voids of nearly empty space between them. It is an architecture so immense that it truly challenges our ability to comprehend it. Our own corner of this cosmic web has been mapped and given a fittingly majestic name, Laniakea, which means immeasurable heaven in Hawaiian. Laniakea is the supercluster that contains the Virgo Cluster and our Local Group among tens of thousands of other galaxies. It stretches over 500 million light-years. Within this enormous gravitating system, galaxies flow along streams towards a common gravitational center, like islands drifting within a cosmic current. To call it a supercluster of galaxies is to still understate its scale. When we speak the name Laniakea, we invoke the awe of an endless expanse, an apt description of the vast heaven of galaxies we find ourselves in. And yet, Laniakea is only one patch of the cosmos. Beyond our supercluster are countless others. The observable universe, the part of the cosmos we can potentially see, contains an estimated hundreds of billions of galaxies. Each galaxy is an island of stars, with its own billions or trillions of suns. When we try to fathom how many stars exist in all those galaxies, the numbers escape comprehension. Some scientists say there may be more stars in the universe than grains of sand on all the beaches of Earth. Numbers like these boggle the mind. We find ourselves confronted with a cosmos that is not only vast in size, but also rich in number. Standing under the night sky and contemplating this immensity can make us feel very small. Our entire planet is just a tiny mote in a vast galaxy, which itself is just one of countless others. But instead of feeling lost, we can also feel profoundly connected. We are part of this grand tapestry. The atoms in our bodies, the light in our skies, the ground beneath our feet, all are pieces of the universe. In knowing this, our sense of awe is accompanied by a sense of belonging. We are at once humbled by our smallness and elevated by our connection to all that exists. Now, let us imagine journeying far away from our familiar earthly vantage. Suppose we could travel outward, leaving the solar system and then the Milky Way far behind. As we venture into intergalactic space, we would see our Milky Way shrink in the distance, from a luminous band to a pale, tiny lens of light hanging in the blackness. The familiar constellations would dissolve, their stars fanning out in 3 dimensions. We would watch the great spiral of our galaxy become just another faint shimmer among others. Drifting further, we find ourselves in a silent gulf between galaxies. Around us, the nearest lights are the soft halos of our galactic neighbours in the local group. The Andromeda Galaxy would be there, a majestic spiral just a bit larger than our Milky Way, shining gently nearby. Perhaps the Triangulum Galaxy, another spiral, would be visible as a small whirl of light. Scattered around are numerous dwarf galaxies, little ellipticals and irregular clumps of stars gathered around the giants. Altogether, they form our little island group in the cosmos. Out here, with the Milky Way behind us, we would truly sense how isolated each galaxy is, separated by vast, dark oceans of space. If we continue our outward journey, the local group itself begins to shrink behind us. Before long, we would see not individual galaxies, but the faint glimmer of the local group as a tiny cluster of lights in the distance. Ahead, we would notice more glows gathering. We are approaching the Virgo cluster, the large cluster of galaxies that our local group calls home. Within the Virgo cluster, thousands of galaxies swarm in a region a few million light-years across, an archipelago of galaxies in the great cosmic sea. Some are enormous ellipticals, glowing like diffuse lanterns. Others are elegant spirals. Many are dwarfs, dim and subtle. From our perspective, the cluster might appear as a hazy cloud of light, where each tiny spark is an entire galaxy. All around us, in every direction, beyond Virgo, lie other clusters and groups, countless assemblies of galaxies stretching into the distance. The farther we look, the more numerous they become, until they fade into a fine haze on the horizon of the observable universe. We truly feel adrift in a cosmic ocean, surrounded by an endless expanse of galaxies, like islands scattered on a dark sea. Far out here, in the space between galaxy clusters, the darkness is almost perfect, and the silence absolute. There is no atmosphere, no sound, only the soft glow of starlight from distant galaxies surrounding us. The emptiness between galaxies is nearly a vacuum. On average, just a few stray atoms drift in each cubic meter of intergalactic space. It is a realm so empty that 2 galaxies could pass through each other and their stars would scarcely collide. And yet this void is not truly empty. It is suffused with the gravitational presence of unseen matter and the faint afterglow of creation that permeates the universe. In this deep, dark quiet, there is no up or down, no horizon or ground, only the infinite expanse extending in every direction. If we pause here, suspended in the velvety darkness, and look back toward where we came from, we might see only a tiny speck of light where the local group is. just a small cluster of galaxies nearly lost in the blackness. Our Milky Way, our home, would be just a minuscule smudge among countless others. Such a perspective is both eerie and serene. The overwhelming vastness could be daunting, but it also carries a profound peace. We are in the middle of nowhere, and everywhere, enveloped by the quiet grandeur of the cosmos. The farther we gaze into space, the further back in time we see. Light from distant galaxies takes millions or even billions of years to reach us, so we observe those galaxies as they were long ago. In fact, some of the galaxies visible in deep telescopic images are seen as they were billions of years in the past, their light having left them when the universe was young. Peering into these depths is like reading ancient history written in light. Bit by bit, the universe has revealed its story to us. How galaxies grew and clustered, how stars were born and died, and how, out of a hot primordial beginning, this magnificent cosmic structure evolved. And yet, for all we have seen, there remain mysteries beyond our reach. Beyond the horizon of our vision, the universe likely continues far, perhaps infinitely, with wonders we can scarcely imagine. Still, standing under the stars, we can feel that vast history and expanse without seeing it directly. The starry sky connects us to cosmic time as well as space. In its quiet way, it tells us that the universe is very old and very large, and that whenever we look up, we are looking into deep time as well as great distance. Here, at what feels like the edge of the universe, let us pause and reflect on the voyage we have taken in our minds. We began on Earth at dusk, with the soothing fade of daylight and the first stars appearing in the twilight. We stood under a starry sky, surrounded by the same constellations that guided and inspired our ancestors. We marveled at the Milky Way's glowing arch, discovering that our galaxy is both our home and a vast, stellar community beyond our everyday reach. We then pushed further outward, imagining the myriad galaxies that lie beyond our own, traversing the cosmic ocean with our thoughts. Step by step, we journeyed across the cosmos, traveling far in distance and time, until our planet, our sun, even our entire Milky Way, were just tiny points in a sea of galaxies. It has been a voyage both outward and inward. Outward to the grandest scales of space, and inward to a deeper understanding of our connection to the cosmos. Now, drifting in this reflective space, we find a profound peace. The immensity around us puts our lives into perspective, yet it also comforts us with a sense of unity. Under the canopy of stars, amidst the glow of galaxies, we feel both tiny and tremendously linked to everything. The silent night envelops us, and in that silence, we can almost sense our own hearts echoing the calm of the cosmos. The night sky has opened our eyes to the grandeur of existence and our hearts to the beauty of all that is. We will let this feeling linger as we gently return our awareness to the present moment. Though we pause our cosmic journey here for now, the story of the universe continues, endless and beckoning. The stars above, in their silent language of light, encourage us to look further and dream deeper. The cosmic ocean stretches out before us, vast and unexplored. Let us rest here for the time being, cradled in starlight, our spirits calm, our curiosity alive. The voyage will go on under these galactic nightscapes as we continue to explore the infinite, one gentle night at a time. In the silent reaches of a galaxy's vastness, a gentle glow emerges from the darkness. We drift closer, carried on an endless cosmic breeze, and before us unfolds a luminous cloud adrift among the stars. This is a stellar nursery, a cradle of stars tucked within veils of interstellar dust. Here, in these tranquil cosmic cradles, new suns are quietly awakening. They form, deep inside, great clouds of gas and dust that stretch across light years, cold and dark, until the first sparks of starlight begin to glimmer from within. Often, the process starts subtly, perhaps a ripple or a distant echo of an ancient supernova nudges part of the cloud to begin collapsing. From that moment, gravity takes over, pulling more and more material into dense clumps. In the void of space, a slow gathering of light is underway. Within one such nebula, starlight softly paints the surrounding gas in delicate hues of rose and violet. The colours of this cosmic cloud are the result of its chemistry and its stars. Hydrogen atoms, excited by newborn suns, glow in pink and red, while traces of oxygen add faint green, and dust grains scatter blue light. It is as if the nebula were a great canvas, painted in translucent washes of colour by the energy of nascent stars. Towering pillars and filaments of dust twist and swirl, silhouetted against the glowing backdrop. Inside these obscuring columns, the real magic is hidden. Clumps of matter drawing together under the pull of gravity, growing denser and hotter over countless millennia. In time, each clump will ignite into a newborn star. For now, they lie ensconced in their dusty cocoons, gathering strength and preparing for the moment they will shine. The nebula around us is alive with quiet activity. Though no sound can travel in the vacuum of space, one can almost sense the gentle stirrings of creation. Tiny grains of cosmic dust collide and cling together. Wisps of gas flow and eddy, guided by physics and chance. Here and there, faint points of light reveal where a new star has just kindled. These infant suns are still swaddled in nebulous shrouds, their light tinted and softened by the clouds that formed them. For every such glimmer we detect, many more newborn stars remain hidden in the cloud's opaque depths. A giant nebula like this can ultimately give birth to hundreds of stars over its lifetime. From brilliant blue-white giants that burn fiercely, to small red dwarfs that will glow faintly for billions of years. It is a slow, silent blossoming of starlight on a colossal scale. In some corners of the nebula, the newborn stars make their presence known in dramatic ways. We catch sight of slender jets of gas shooting out from deep within a dark globule, like narrow beams from a lighthouse cutting through cosmic fog. These are the outflows of a forming star, twin jets of plasma launched from its poles. They pierce the surrounding gloom and crash into the nebular material farther out, causing it to glow where they strike. Each jet creates a small, radiant splash in the darkness, signposts that a protostar is spinning up in the cloud, still wrapped in darkness, but already announcing itself with these cosmic beacons. Occasionally, a brighter flash illuminates the murk. A particularly massive newborn star has burst into life. Its fierce radiation carves through the surrounding gloom, creating pockets and cavities in the nebula. Stellar winds, streams of charged particles flowing outward at high speed, push the gas outward like a celestial breath. The nebula responds, sculpted into intricate shapes, elongated pillars, hollow shells, rippling ridges of glowing gas. Each shape is a frozen moment in time, an ongoing dialogue between the newborn stars and their birth cloud. In one famous stellar nursery, the Eagle Nebula, Such pillars rise out of the cloud like giant ghostly mountains. We have nicknamed them the Pillars of Creation, for they are columns of interstellar dust and gas where new stars are being born at this very moment. They stand silhouetted against the nebula's faint glow, their tips illuminated by hidden stars, slowly evaporating under the onslaught of starlight. Scenes like these remind us that even as a star's light destroys the cradle that nurtured it, that very act reveals the star to the cosmos. In one corner of this cosmic nursery, a cluster of infant stars has emerged from its dusty womb. They gleam together in a tight grouping, their combined light bathing the nearby clouds in a gentle radiance. Some shine blue-white, exceedingly hot and brilliant. Others are golden or red, cooler, but still full of youthful fire. This cluster will remain bound together for a time, a family of stars sharing a common origin, before gravitational tides slowly disperse them across the galaxy. Perhaps in 100 million years, these siblings will drift so far apart that they no longer remember they were born together, each continuing its journey alone around the galactic center. But for now, they cling together, a glittering siblinghood of new suns, illuminating the remnants of the nebula that gave them birth. We drift onward through the nebula's expanse, moving slowly, as if careful not to disturb the fragile creation unfolding around us. Delicate tendrils of gas float past in luminous wisps. Here the light is soft and diffuse, giving the impression of a gentle cosmic dawn breaking in the interstellar night. In the far distance, we catch sight of another nursery, the faint outline of a different glowing cloud, where yet more stars are forming. Indeed, the Milky Way is sprinkled with thousands of such cradles of stars. They lie hidden within the spiral arms of the galaxy, often cloaked by dark lanes of dust when viewed from afar. Some, like the great nebula in Orion, are near enough to Earth that their glow can be seen even with the naked eye on a clear night. A tiny patch of hazy light hanging beneath Orion's belt, marking a stellar nursery about 1/300 light-years away. That very nebula has captivated skywatchers for millennia. The ancient Maya, seeing that faint smudge in the night, imagined it as the cosmic fire of creation burning in the heavens. Unknowingly, they were insightful. In that misty glow, new stars truly are being born, their light just beginning to escape the shroud. Other nurseries are more remote and shrouded, revealed only by the penetrating gaze of telescopes that can detect the infrared warmth of forming stars or pick up the faint radio whispers of molecules in the dark. But whether near or far, each stellar nursery is a beacon of creation, a place where the galaxy renews itself by forging new stars from the raw material of space. As we finally leave the heart of the nebula, the starlight around us grows sharper and less diffused. We pass out of the cloud into clearer space and glance back at the glowing celestial cloud we have traversed. Its once dark interior is now peppered with the soft radiance of young stars, like fireflies illuminating a fog. Over millions of years, that nebula will continue to change and evolve. More stars will take shape within it, and the accumulating energy of their starlight and stellar winds will gradually disperse the remaining gas and dust into the wider galaxy. In the end, the nebula will lose its luminous form, fading back into the interstellar medium from which it came, but its stellar children will remain, drifting away into the galaxy at large and carrying with them a piece of their birthplace. The galaxy will remember their origin, for those stars, wherever they travel, bear in their composition the chemical fingerprints of the nebula that formed them. In their light, and in the atoms that will one day stream from them in solar winds or in the gentle shells of their own future nebulae, they carry the story of their cosmic nursery. Each star is a keeper of that memory, a bright testament that out of cold darkness, light and life can emerge. Moving beyond the nebula, we enter a richer starfield. Freed from the obscuring dust, the cosmos reveals a vast tapestry of stars on all sides. Each star shines with its own hue and brightness, like a multitude of gemstones scattered across a black velvet expanse. We are surrounded by these celestial jewels, each one a distant sun. Some are solitary and faint, perhaps humble red dwarfs, glowing with a ruddy light that belies their long, steady lives. Others are brilliant beacons, enormous blue-white giants, many times the mass of our sun, pouring out torrents of energy and dominating their corner of space with searing intensity. Against the deep darkness, their colours stand out, subtle oranges and golds, icy blues and pure whites. Out here in space, far above any atmosphere, the starlight is steady and unwavering. The familiar twinkle we see from Earth is gone, replaced by a serene, constant gleam. As we drift through this stellar ocean, it's easy to see how humanity has always been enchanted by the night sky. From our vantage on Earth, people connected the brighter stars into constellations, imagining heroes, creatures, and gods traced among the heavens. They saw a mighty hunter in Orion, a great bear turning eternally around the North Star, a swan gliding along the Milky Way. These patterns were our way of finding familiarity and meaning in an overwhelming sea of lights, helping ancient navigators find their way and storytellers weave cosmic tales. Yet here, among the stars themselves, we sense how much grander reality is. Many of the stars that appear close together in a constellation are in fact separated by vast gulfs of space, related only by our line of sight. The figures our ancestors drew are beautiful coincidences of perspective. Still, the stories and names we gave the stars reflect our deep desire to connect with the cosmos. Even now, knowing what these lights truly are, we feel a kinship with those early stargazers. The constellations remain our cultural companions as we traverse this ocean of stars. Spread before us is the Milky Way's grand panorama, billions upon billions of stars strewn like glittering dust across the black. We are travelling through one of the galaxy's spiral arms, a curving river of starlight, gas, and dust that winds its way around the galactic centre. In this particular segment of the galaxy, known as the Orion Arm or local spur, our own sun resides. Our sun is just one modest star here, a gentle yellow beacon residing in a quieter region of the arm, about halfway out from the galaxy's centre. As we float along this starry thoroughfare, we are reminded that our sun, along with all its planets, is orbiting the galactic centre at an immense speed. Yet the galaxy is so vast that a full circuit takes on the order of 230 million years. In the 4.5 billion years since our sun was born, it has completed roughly only 20 of those grand rotations. To us, such spans of time are almost unfathomable, millions of years, hundreds of millions. But to the galaxy, a single turn is a common cadence, a heartbeat in the life of a galaxy. We imagine that somewhere among these distant suns, there are countless worlds with their own skies and maybe their own observers. By now, astronomers have discovered thousands of planets orbiting other stars, exoplanets of every kind, and they suspect that the majority of stars have at least one planet in tow. It's humbling and thrilling to consider. the number of worlds in our galaxy likely reaches into the billions. If we pause to reflect, that means billions of skies with their own unique starry nights. On some of those worlds, the Milky Way might arch overhead in a glorious band, just as it does from Earth, inspiring wonder in any eyes turned upward. On others, perhaps in a binary star system, two suns might dance in the sky, casting double shadows on alien landscapes. And maybe, on a distant planet, orbiting a star, in this very spiral arm, a being looks up and sees the band of the Milky Way, and one particular star within it, our Sun, as just another tiny point of light. To them, it would be inconceivable that that faint star hosts a blue planet where other creatures gaze back. Yet here we are. The thought gently reminds us that the universe, for all its vastness, is full of shared experiences, a cosmic kinship among those who observe the same stars from different shores. Every star in this cosmic ocean has its own story. Some journey through space with companions. We glide past a magnificent double star system. One member of the pair is a bloated red giant, glowing with a coppery light, and its partner is a smaller, intensely hot blue-white star. They orbit one another in a slow, elegant, gravitational dance. From afar, their blended light might appear as a single point, but up close, the contrast is striking. A cosmic duet in colour, two stars, different in hue and age, yet bound together by invisible threads of gravity. There are countless binary and multiple star systems in the Milky Way. In some, the stars twirl so closely that they exchange matter or eventually merge in a brilliant flash. In others, they keep a courteous distance, orbiting tranquilly for eons. If we had time to visit them all, we would find marvels. Suns eclipsing each other in mutual orbits, stars whose combined light fluctuates as they take turns hiding one another, and planets with 2 or 3 suns painting their skies. The variety of arrangements is endless, yet each obeys the same gravitational choreography. Elsewhere, we glimpse a tight knot of stars, glittering like a pocketful of diamonds against the dark. Drawing nearer, we realize it is an open star cluster, a group of young stars that were born together and still linger in each other's gravitational embrace. Perhaps it resembles the Pleiades, the 7 sisters that grace Earth's night sky on winter evenings. In our mind's eye, we overlay that familiar cluster onto this scene. Several bright blue stars gathered in a tiny cluster, still wrapped in a delicate gauze of glowing dust that reflects their light, the remnant of the cloud that formed them. The Pleiades themselves, around 410 light-years from Earth, are so prominent that nearly every culture has given them a name and a story. To the Greeks, they were sisters pursued by a hunter. To the Maori, they were a sign of the new year. To many, a symbol of unity or an omen of the seasons. Strangely, most people with sharp eyes can only discern 6 stars in the Pleiades, not 7, a fact that birthed legends of one lost sibling. Through a telescope, however, dozens more stars appear, and long-exposure photographs reveal the faint blue haze of the reflection nebula that the cluster is ploughing through. These stars are only about 100 million years old, youngsters by stellar standards, and they will drift apart over the next few 100 million years. But for now, they remain a beautiful, tight-knit family of suns, an oasis of light in the dark vastness. Not far from such clusters, the galaxy offers other treasures. In the southern hemisphere's sky, near the constellation of the Southern Cross, lies a tiny cluster aptly named the Jewel Box. To the naked eye, it appears as a faint, blurry star, but through a telescope, it explodes into a spray of colourful lights. Its brightest stars shine in different hues, one a vivid ruby red, others blue and white, creating the effect of a handful of precious gems scattered on black velvet. This compact cluster is relatively small, but its striking colours have made it famous among stargazers. It is a reminder that nature's beauty often lies in contrasts, hot young stars and cooler older ones mingling together, painting the darkness with subtle shades. Clusters like the jewel box dot our galaxy's spiral arms, each a pocket of brilliance and colour, each the legacy of a long-dissipated nebula that gave birth to its stellar jewels. Not all the jewels of the galaxy shine forever. Some live fast and die young, ending their lives in spectacular fashion. As we float through this region of the spiral arm, we find evidence of stars that have already met their end. To our left, a faint, gauzy ribbon of glowing gas drifts in space, as delicate as a silk scarf. It is tinted with subtle hues, a soft red from hydrogen, a ghostly green-blue from oxygen. This ethereal structure is a supernova remnant, the expanding cloud of debris from a massive star's explosive death. Long ago, that star ended its life in a titanic supernova, a detonation so bright it may have been visible from Earth with the naked eye, perhaps even in daylight for a few weeks or months. For a brief moment in time, that single star outshone entire galaxies. The explosion hurled the star's outer layers into space at millions of miles per hour, creating an expanding shock front. Now, centuries or millennia later, those fragments have spread out into this intricate filamentary web. They glow faintly as they plough into the thin gas of the interstellar medium, energizing it and making it fluoresce. What we see is like the ghost of a firework, lingering long after the initial burst, a delicate tracery of illuminated gas, marking where a star once shone. Though born of violence, the sight before us is strangely peaceful. The supernova's aftermath has become a beautiful, quiet nebula in its own right. A cosmic flower blossomed and now slowly dispersing its petals across the stars. The once deafening explosion is eons past. Now there is only silence, and the gentle glow of gases cooling and fading into space. We observe the thin, veil-like filaments with a sense of reverence. They span dozens of light years, yet are so tenuous that if we were to fly through them, we might not even notice, aside from a slight uptick in radiation. Over tens of thousands of years to come, these wisps will merge into the surrounding interstellar medium, enriching it with heavy elements, oxygen, carbon, iron, and more. The ashes of the star that are destined to become the seeds for new stars and planets in the future. A little closer to us floats a smaller, perfectly symmetrical glowing orb suspended in the darkness, like a celestial bubble. We move toward it and find ourselves gazing at a planetary nebula. Despite the name, this has nothing to do with planets. It earned that label because early astronomers with small telescopes thought these round nebulae resembled the disks of distant planets. In truth, we are witnessing the peaceful death of a sun-like star. When a star of moderate mass nears the end of its life, it cannot sustain the nuclear reactions in its core that fight against gravity. The core begins to contract, heating up, and the outer layers of the star puff out and drift away into space. The star gently sheds its atmosphere, creating an expanding shell of gas. At the center, the hot core that remains, now a white dwarf, pours out intense ultraviolet light. That radiation strikes the receding gas and makes it glow in vibrant colors. The result is a luminous bubble or ring of gas, hanging in space like a delicate soap bubble or a halo. Often these nebulae display intricate, symmetric patterns. Some appear as simple rings, others as hourglass shapes or bipolar lobes, and still others as complex, multi-shell structures that baffle the eye. Each planetary nebula is like a unique cosmic snowflake, no two exactly alike. We linger for a moment by one such nebula, marveling at its fragile beauty. It hangs in the void like a tiny iridescent jewel, an opal forged from stardust, marking where a star has quietly cast off its outer vestments. Pale blues and greens glow from ionized oxygen and hydrogen, and hints of red where nitrogen is present. The central white dwarf star can often be seen as a pinprick of white-hot light, illuminating its creation. This ethereal vision is transient. In only 10 or 20,000 years, a mere eye blink on galactic timescales, the nebula will disperse into space, its constituent gases mingling with the interstellar medium. Yet for this short period, the planetary nebula is a gorgeous farewell gesture, the star's final gift of light to the universe, and a promise that the material it releases will someday be part of new stars, new planets, even new life. These remnants of death are also seeds of creation. The scattered gas and dust thrown off by dying stars will eventually mix with the great molecular clouds of the galaxy, contributing material for the next generation of suns and worlds. In this way, the Milky Way constantly regenerates itself. The death of stars, both gentle and violent, replenishes the raw ingredients in space, which gather again into new stars. The atoms of a long-gone star might become part of a nebula that gives birth to new solar systems, part of a newborn star's planets, or even part of living beings who might one day marvel at the night sky. In fact, we ourselves carry pieces of this cosmic history. The carbon in our cells, the calcium in our bones, the iron in our blood. These atoms were forged in stars that shone long before our sun existed. Some came from stars like our sun, swelling into red giants and shedding their outer layers calmly. Others came from massive stars that blew themselves apart in supernova fury. Those elements floated through space, gathered into the cloud that formed our solar system, and became part of us. The cosmos recycles everything. Nothing is wasted, and every atom in our bodies has passed through multiple stars and spaces to be here now. Every brilliant supernova explosion and every gentle wafting away of a planetary nebula enriches the galaxy with heavy elements, the building blocks of planets and of life as we know it. Over billions of years, this gradual enrichment has transformed our galaxy from one filled with only the lightest elements into one speckled with the chemistry that can produce rocky worlds and living creatures. Through this ongoing cycle of stellar birth, death, and rebirth, the galaxy's sparkling tapestry is continuously rewoven, generation after generation. Drifting onward, we notice the starry vista ahead growing denser and more luminous. Unbeknownst to us, we have been journeying gradually toward the central region of the Milky Way. The change has been subtle at first, an extra star here and there, but now it becomes unmistakable. The number of stars around us has increased dramatically. What was once a dark background between individual stars now appears as a faintly golden haze. This diffuse glow is the combined light of countless distant stars overlapping one another, too tightly packed for the eye to separate. Interstellar space here also contains more fine dust, which casts a delicate veil over the starlight and gives it a warm tint. We realize we are approaching the galactic heart, where stars crowd together in a great central bulge. As we move deeper into this teeming region, our sense of scale shifts profoundly. The stars are far more numerous now than in the quiet spiral arm we came from. They surround us like grains of sand in a cosmic desert, so abundant that individual points of light begin to blend into a continuous glow. The illumination around us is a soft, omnipresent radiance, as though we are immersed in a luminous mist. It feels as if we are descending into the core of a brilliant nebula of stars. There is no true night here, no dark backdrop, only layers upon layers of starlight, stretching out in every direction. It is akin to standing in a vast field of fireflies on a summer night, where the air itself seems to glow because there are so many tiny lights all around. Everywhere we look, there are flickers of brightness, close and far, bright and faint, overlapping in an endless profusion. Toward the very center of the Milky Way, the character of the starlight changes subtly. Many of the stars here are extremely old. They have been shining for perhaps 10 or 12 billion years, nearly as long as the galaxy itself has existed. These ancient suns have used up much of their fuel and swollen into red and orange giants. They cast a steady, cool, golden light, like late afternoon sunlight gilding a landscape. The combined effect of countless such stars is a gentle golden glow suffusing the core. Intermingled with these elders are younger, hotter stars too, the products of more recent star formation that can occur even in the central regions when clouds of gas are driven together. This means the light here isn't uniformly red or gold. In patches, it's tinged with blue-white, where clusters of massive young stars burn intensely. The galactic center hosts stars of all ages, a cosmic crowd of multiple generations gathered in one place. Occasionally, among the throng, a star will pulsate as a variable, its brightness rising and falling in a steady rhythm like a heartbeat. These rhythmic changes add a subtle flicker to the glow, as if the galactic heart has its own slow pulse. The environment here is energetic in ways that are not immediately visible to human eyes. Clouds of gas are being pushed and pulled by gravitational forces and by past supernova shockwaves. If we could see in infrared or radio wavelengths, we would observe complex structures, arcs and streamers of gas, some forming a twisted ring around the very center, churned by magnetic fields and the gravitation of the central black hole. Astronomers using such instruments have discovered that new stars still form in this crowded center, though the process may be turbulent. Perhaps when smaller galaxies in the past merged with the Milky Way, or when spiral density waves directed material inward, they created pockets of gas, dense enough to collapse into stars, even amid the chaos. We pass near one such region, invisible to us in optical light, but glowing brightly in infrared. It's a cluster of hefty newborn stars, hidden behind dense dust, a miniature stellar nursery thriving here against the odds. The presence of these clusters reminds us that the central region is not just a stellar museum of ancient relics. It is also a place of ongoing change, where the cycle of birth and death continues in a more rapid and intense mode than out in the galactic suburbs. From our terrestrial vantage on Earth, the heart of our galaxy is hidden from view by enormous intervening clouds of dust. If one looks toward the constellation of Sagittarius on a clear summer night, one sees a rich, milky glow in the sky, split by dark rifts. That glow is the dense star fields of the inner galaxy, and those dark rifts are the dust clouds obscuring the center. For centuries, humans had no idea what lay at the core of the Milky Way, because visible light cannot pierce that dust. It was only with the advent of radio telescopes and infrared cameras that we began to sense the bustling heart behind the veil. But here, on our journey, we are free to behold it directly. We drift past the curtain of dust and into the inner sanctum. In our mind's eye, we see the architecture of this region. Whirling clouds, feathery nebulae lit by hidden star clusters, and stars upon stars crowded into a volume of space that would seem impossibly small to contain them all. And at the very hub of this vast wheel of stars lies something extraordinary that governs much of the dynamic of the central region. At the exact center of the Milky Way, there is a great gravitational presence, a dark anchor around which the entire galaxy swirls. We cannot see it with our eyes, for it emits no light of its own. It is a supermassive black hole, containing the mass of roughly 4 million suns, crushed into a space no larger than our solar system. Here, gravity reigns supreme. The space around this black hole is warped and fierce. Stars in the innermost orbits around the center whip through space at astonishing speeds, like comets on steroids. We imagine their trajectories, elongated ellipses that carry some of them perilously close to the central void before flinging them back out. These stars complete an orbit in mere years or decades, a blink of an eye in cosmic time, a testament to the intense gravitational pull at the galaxy's core. One particular star, known to astronomers as S2, has been observed to make a full loop around the central black hole in about 16 Earth years. At its closest approach, it comes within just a few light hours of the black hole, closer than Neptune or Pluto is to our Sun, and it swings around that bend at a tremendous velocity of thousands of kilometers per second. There are dozens of such stars, known as the S-stars, zipping around the invisible center in a sort of celestial dance that defies our everyday intuition. If we focus our attention toward the core, we can almost feel the movement. Stars moving like sprites, here one moment and over there the next, though in reality their motion, while fast, still appears slow to an observer. It takes weeks or months for their positions to noticeably change. These stars are our proof that something unimaginably massive, yet unseen, sits at the galaxy's center, directing the dance. Yet despite all this dynamism, from our viewpoint, at a respectful distance, the black hole's domain appears tranquil and oddly empty. We do not witness any blazing accretion disk or jets of energy at this time. The Milky Way's central black hole is relatively quiescent compared to those in active galaxies known as quasars. We sense the black hole's presence primarily as a deep well of silence, a still, dark heart at the center of all the swirling starlight. It's an almost spiritual contrast. Amidst the brilliance of billions of stars is a well of perfect blackness, a void so deep that not even light can escape it. It is as if all the commotion of the galactic center has, at its very core, an oasis of stillness. This dark center holds the Milky Way together in a literal sense. Its gravity helps keep the stars in their orbits, and perhaps also in a figurative sense, for it is a reminder of the mysteries that even in the brightest of places there can be impenetrable darkness. All around this central black hole, stars and star clusters orbit in complex patterns. Some of these clusters rank among the densest in the galaxy, packed with hundreds of thousands of stars. We drift through one such cluster near the core, feeling the combined gravity of so many stars tugging gently at us from all sides. The starlight here is intense. Thousands of stars gleam around us at distances far closer than any star neighbor we have back near our sun. The sky from within this cluster would be breathtaking, perhaps comparable to how Earth's sky appears at twilight. The light of so many nearby suns would bathe everything in a diffuse glow. Even here, though, night would still fall in some sense, because not every direction has a bright star. If you stood on a planet in the midst of this cluster, you would never experience a sky anywhere near as dark as what we call night on Earth. Multiple brilliant stars would cast overlapping shadows. The concept of a lone North Star would be meaningless when dozens of stars outshine anything in our terrestrial sky. And yet, even amid such brilliance, an eternal night still reigns beyond a certain point. Look past the cluster's boundary, and the infinite depths of space are still black. There is always more darkness between the stars, even in this most crowded of neighborhoods. Every so often, a star reaches the end of its life here as well, and a supernova punctuates the steady glow with a momentary flash of brilliance. Such explosions in the core might be more frequent than in quieter galactic suburbs, simply because there are more massive stars here to begin with. Over millions of years, each supernova contributes its share to the enrichment of the central environment, just as similar events do out in the spiral arms. The heavy elements thrown out by these explosions eventually seed new stars and planets that form later. Even in the galactic center, the cycle of matter continues. The black hole, too, can make its presence known indirectly. Its strong gravity sometimes sends stars careening off on new trajectories. A close gravitational encounter can fling a star out of the cluster, or even entirely out of the Milky Way, as a so-called hypervelocity star destined to wander intergalactic space. Conversely, the black hole occasionally draws in a drifting cloud of gas or an unlucky star that ventured too near. When it does, that material spirals in and heats up, flaring brightly in X-rays for a short time, a brief beacon signaling that the sleeping giant has claimed another meal. At the moment, however, no such feeding is happening that we can see. The black hole is calm, merely exerting its silent pull on everything around. The center of the Milky Way is a place of extremes, of gravity, of stellar density, of both age-old stars and transient high-energy phenomena. Yet when taken as a whole, it is enveloped in a soft, golden-white radiance that, from afar, appears gentle and unchanging. Seen from Earth's distance, the tumultuous core is just a warm glow hidden behind dust. Up close, we see the frenzy, but we also detect a kind of equilibrium. It is a bustling cosmic city, full of activity and energy, but it has been like this for millions of years and will remain so for millions more. There is a sense of permanence to the glow. In that endurance, there is calm. After spending some time immersed in the cosmic bustle of the galactic heart, we begin to journey outward again. Slowly, gradually, the density of stars around us decreases. The soft golden background light that once bathed every corner begins to dim, and individual stars once more step forward from the collective glow. We retrace our path out of the central bulge, moving back through the plane of the galaxy's disk. It's as though we are climbing out of a luminous valley and onto more sparsely populated highlands. The crowd of stars thins from millions per cubic light-year to hundreds of thousands, then to mere thousands, and still it continues to decline the farther we go. Passing through the inner spiral regions again, we recognize some familiar sights from a new angle. We drift past clusters of stars and glowing nebulae that we saw on our way inward, now with the brilliant central hub fading behind us. The perspective is different. The light from behind silhouettes some clouds and illuminates others in reverse. Before us, the spiral arms unfold once more. If we could hover above the galactic plane now, we might trace the elegant sweep of the arms spiraling out from the core. But within the plane, we experience them as alternating bands of richer and sparser star fields. We sense the repeating rhythm of the galaxy's structure. We move through a dense region of stars and nebulae, an arm, and then into a relative void, an inter-arm gap, and then into another arm further out. This pattern is the grand design of our spiral galaxy, and we are travelling through its broader strokes. Our journey continues further and further outward. We leave behind the bright bustle of the inner galaxy and venture into the quieter outskirts. Here the spiral arms themselves begin to lose their distinctness. The stellar population grows thinner, star clusters are few and far between, and glowing nebulae are rarer. We are entering the galactic frontier, a realm marked by wide gulfs and a profound hush. The night deepens out here, as fewer stars remain to light the void. Those that do appear are often older, dimmer stars, or perhaps the occasional young star that found itself born far from the crowd. Even the interstellar gas is thinning out. The great reservoirs of material that fuel star birth are mostly behind us now toward the centre. Out here, only wisps of hydrogen clouds linger, and many of those may never coalesce into new stars. It is as if we have reached a countryside beyond the galactic city, a sparsely populated expanse where solitude reigns and change comes slowly, if at all. Pausing here on the outskirts, we allow ourselves to look back toward the centre we have left. From this far vantage, tens of thousands of light years away, the Milky Way's core is just one glow among many. In fact, the entire galaxy presents itself to us as a ghostly band of light encircling the sky. Much as we see the Milky Way from Earth on a clear, dark night, here we witness it in truly pristine clarity, unfiltered by any atmosphere. The collective glow of all the stars we traversed merges into a luminous river of light. That river of stars broadens and brightens toward one direction, marking the central bulge of the galaxy as a concentrated, oval glow. We see dark ribbons bisecting the band. These are the great dust lanes in the disk, still blocking some light from the far side of the galaxy. The view is breathtaking and humbling. We are gazing at our home galaxy from within, but near its edge, seeing it as a whole made of uncountable parts. The Milky Way stretches across the sky, a testament to both the vastness of space and the unity of this collection of stars bound together by gravity. The Milky Way is an island in space. It is a spiral disk of roughly a few 100 billion stars, drifting through the cosmos with its retinue of smaller satellites. Were we to measure its diameter, we'd find it spans about 100,000 light-years from end to end. Even a beam of light, racing at 300,000 kilometers per second, would require 100 millennia to travel across it. Such is the immensity of our galactic home. And yet, from this edge-on perspective, it also seems finite and knowable. We can see the faint thinning of stars at the extremities of the disk. We can trace the soft curve of the spiral arms fading into darkness. In the grander scheme of the universe, our Milky Way is but one galaxy among countless others. As we peer outward, beyond the edges of our galaxy's light, we become aware that we stand on a cosmic shoreline. The sparkling waters of our galaxy end here, and the great dark ocean of intergalactic space lies ahead, sprinkled with the lights of other distant galaxies. Before our gaze turns fully outward to those far-off realms, we linger a while at the frontier of the Milky Way. In this sparsely populated domain, a profound peace prevails. A lone star might shine here for hundreds of light-years in all directions without a close neighbour. If a planet circles that star, its night skies would be nearly black, perhaps only a few dozen faint stars visible to the eye, and the sweeping glow of the Milky Way as a hazy arch. Some of the stars out here may have been born in the outskirts, in small, isolated clouds that managed to condense on the margins of the galaxy. Others could have been flung outward from the inner regions. Exiles sent on long journeys by gravitational encounters or past mergers of the Milky Way with another galaxy. And a few might not originally belong to the Milky Way at all, instead being immigrants, stars from a smaller galaxy that was absorbed by ours, now roaming the halo far from the original point of collision. In their isolation, these peripheral stars live out quiet existences, burning their fuel slowly and steadily, with only the vast dark for company. We come upon a spectacular sight, suspended high above the galactic plane, a globular cluster hanging like a lantern in the darkness. This is one of the Milky Way's many globular star clusters, ancient, densely packed spheres of stars that inhabit the galactic halo. In fact, dozens of globular clusters encircle our galaxy, each one containing anywhere from tens of thousands to perhaps 1 million very old stars. Up close, the cluster is a marvel. Imagine 1 million suns crammed into a ball only a few dozen light years across. At its core, stars are so crowded that the average distance between neighbouring stars might be only a few light months or less. In comparison, our nearest stellar neighbour to the Sun is over 4 light years away. Some stars in such clusters actually do interact or collide over eons, producing exotic phenomena like merged blue straggler stars that seem surprisingly youthful amid their companions. The cluster we observe glitters with countless pinpoints of light, a concentrated bonfire of stars against the darkness. Many of its stars are red and orange giants, elderly and majestic. Others are dimmer, sun-like stars that have been shining since nearly the dawn of the galaxy, gradually using up their fuel. The whole cluster swirls slowly about its centre, held together in a tight embrace by gravity. Such clusters wander the outskirts of the Milky Way, forever bound to the galaxy's gravitational field. They often follow long, looping orbits that carry them far above and below the galactic disk. In their motions, they trace out the spherical halo of our galaxy's true extent. The globular clusters are relics of an era when the Milky Way was young. They are among the oldest structures in the galaxy. The stars inside them are typically very metal poor, meaning they contain only tiny traces of elements heavier than helium. This tells us these stars formed before generations of supernovae had enriched the galaxy with heavier elements. They are fossils from a time when the universe itself was only a few billion years old. Seeing them now, still shining, is like peering back into time. They have witnessed the Milky Way's evolution over nearly the entire life of the universe. In their steady, collective glow, there is a sense of continuity. They will likely outlast many of the changes to come as well, orbiting peacefully as the galaxy continues to evolve. Beyond even the globular clusters, the halo continues outward, but its inhabitants thin to almost nothing. A few solitary stars might be found many tens of thousands of light years beyond, perhaps flung out on wild orbits. But mostly, what lies beyond is an invisible domain dominated by something we cannot directly see. Our galaxy, like others, is enshrouded in a vast halo of dark matter, an unknown form of matter that does not emit light, does not reflect it, and does not interact electromagnetically in the way normal matter does. We know of its existence only because of its gravity. The stars in the outer parts of the Milky Way orbit faster than they would if only the visible mass were present. It is as though an extra gravitational force is at play, keeping them bound and moving at high speeds. This is the influence of the dark matter halo, extending well beyond the visible edge of the galaxy, perhaps out to several 100,000 light years or more. Here on the verge of our galaxy's observable extent, we cannot see the dark matter halo, but we can feel its effect as a kind of reassuring tug that tells us we are still within the Milky Way's broad, invisible embrace. Now we truly reach the edge of our galaxy's stellar ocean. Before us lies an almost boundless expanse of empty space, the intergalactic gulf separating us from other galaxies. Crossing this boundary is like stepping off the edge of a bright, familiar porch into a dark, open field at night. The soft glow of starlight that once surrounded us falls away behind. Looking forward, the darkness ahead seems even deeper and more absolute. The distances between even the sparse outer halo stars increase until there are no more stars at all in our vicinity. The void in front of us is not completely empty, of course. It contains the occasional stray atom, a few photons from the residual afterglow of the Big Bang, and the gravitational influence of distant masses. But to our senses, it is a perfect black, cold vacuum. Yet even this darkness is not truly absolute. Given a moment for our eyes, and perhaps instruments, to adjust, we begin to discern the faintest glimmers of light in the distance. Just above the plane of the Milky Way, we notice a dim, diffuse patch of light, like a tiny wisp of cloud. This is the Andromeda Galaxy, our Milky Way's nearest large galactic neighbour. Although it is over 2 million light-years away, it contains 1 trillion stars whose collective glow can, under ideal conditions, be just made out as a hazy spot from Earth. From our current perspective, outside the Milky Way's main disk, with no atmosphere to impede us, Andromeda stands out a bit more clearly against the dark backdrop. We see it as an elongated smudge of light, brighter in the centre and tapering toward the edges, the gentle glow of an entire spiral galaxy seen in profile. It is humbling to realize that that faint oval holds as many stars, or more, as our whole Milky Way, and likely its own planets, perhaps life, and stories unknown to us. Andromeda and the Milky Way are bound in a slow dance. In billions of years, they will merge and become one. But such events are far, far beyond any human timescale. And for now, Andromeda simply hangs there, a serene companion island of light across the cosmic sea. As our eyes sweep around the sky, we catch sight of 2 smaller, misty patches of light relatively nearby on the cosmic scale, the large and small Magellanic Clouds. These are satellite galaxies of our Milky Way, at about 160,000 and 200,000 light-years away respectively. They are much smaller than the Milky Way, irregularly shaped and full of young stars, gas and dust. In Earth's southern hemisphere, they appear as faint cloudlets in the night sky, intriguing and static to casual observers and essential navigational markers for early sailors. From our vantage here, we recognize them for what they are: dwarf galaxies orbiting our own. The large Magellanic Cloud, in particular, has its own regions of furious star formation, including the dazzling Tarantula Nebula, a star-forming complex far larger than any in our Milky Way. These little galaxies are like fireflies caught by the gravity of a great tree, circling around it. Eventually, they may be torn apart or absorbed, their stars becoming part of the Milky Way's halo. But at the moment, they remain distinct, adding their own subtle glow to the darkness just outside our galaxy. All around us, as we turn slowly in the darkness, the background is stippled with the faint light of innumerable distant galaxies. Some are so far away that they appear only as tiny, dim flecks, barely distinguishable from stars. Others are grouped together in clusters, their combined light forming a subtle patch of brightness in one part of the sky, perhaps the distant Virgo cluster of galaxies, a massive collection tens of millions of light-years away, which our local group, including the Milky Way and Andromeda, is slowly drifting towards. Everywhere we look, beyond the emptiness immediately surrounding us, there are others. Each faint glow is the sum of billions of stars, blending into a remote whisper of light. The cosmos, it seems, has no end to its variety and number of worlds. Here, at the outermost reaches of the Milky Way, we find a natural pause in our journey. We have travelled from the cradles of stars deep in luminous nebulae, through fields of celestial jewels scattered across the spiral arms, into the crowded heart of the galaxy, and finally out to its furthest edge, where the last outposts of our galaxy give way to the great unknown. The vast panorama of our galaxy lies behind us now, etched across the sky. It is a sight that invites contemplation and humility. Our entire civilization, every human being who has ever lived, every hope and fear, every discovery and creation, has unfolded on a small planet orbiting an unremarkable star, tucked away in a quiet corner of this enormous galaxy. From here, that truth is both humbling and profoundly inspiring. We see the Milky Way as a whole and recognize that, in the grand design of the cosmos, even something as immense as our galaxy can seem small and precious. The Milky Way is our home, a majestic island of light in the dark, and we have come to know it in a way our ancestors could only dream. Yet the journey has also shown us how much more there is beyond. As we prepare to venture beyond, leaving our home galaxy's borders, we carry with us the calm, the wonder, and the reverence that the Milky Way has instilled. Beyond the edge, an even greater ocean of darkness and light awaits. Intergalactic space, with its own mysteries and countless other galaxies strewn across the cosmos like distant constellations of their own. Our journey continues onward, into the deep unknown, under the eternal night sky that has guided us thus far. For now, we float in silence at the threshold of a new expanse, taking one last unhurried look at the serene galactic nightscape of the Milky Way. Its spiral arms and starry bulge stretch across the darkness, a gentle luminescence that has been our companion. We hold that image in our hearts as we finally turn toward the infinite beyond, ready to set our sights on the next chapter of the cosmic voyage. In the silent darkness beyond our home galaxy, we drift into the cosmic night. The Milky Way lies behind us now, a gentle band of hazy light in the distance. Stars that were once our familiar neighbours fade into a delicate glow, merging together until our entire galaxy is but a pale shimmer against the blackness. We have left home, and ahead of us, the universe opens in quiet majesty, vast and unbound. For a moment, we pause and turn to gaze at our own Milky Way from afar. What a sight it is! A broad, silvery disk floating in the darkness, its spiral arms faintly outlined by the glow of billions of stars. From out here, our galaxy is an island of light, adrift in a sea of night, quietly sparkling. All the familiar constellations of our sky are now indistinguishable, blended into that remote haze. Our sun itself is just one humble point within that luminous band, lost among hundreds of billions of others. Seeing our home galaxy as a whole, hanging alone in the void, is both humbling and breathtaking. We carry this image in our hearts as we turn again toward the journey ahead. Far across the void, a faint beacon calls to us, the Andromeda Galaxy. At first, it is only a dim, cloud-like patch suspended in the emptiness. But as we draw closer, its form gradually clarifies. What was a blur becomes a sprawling spiral of starlight. We begin to discern its shape, a bright core surrounded by sweeping arms that unwind in a graceful spiral, dotted with the glimmer of countless suns. Not far from Andromeda, we notice another, smaller galaxy, the Triangulum Galaxy, a delicate spiral companion lingering in the dark. Together with our Milky Way, these are the largest members of our local galactic family. Andromeda, the grandest of the trio, beckons us onward through the night. Between our Milky Way and Andromeda lies a gulf of nearly 3 million light-years of space. In this enormous expanse, there are no planets or moons, no bustling star systems, only a thin scattering of lonely atoms drifting in darkness. The silence here is profound. With no atmosphere to carry sound and no nearby suns to warm the void, we are immersed in an almost perfect stillness. It is a solitude beyond anything on earth, yet it feels peaceful, not empty, as if the cosmos itself is at rest. As we travel toward Andromeda, we realize that even the void is not truly empty. Tenuous wisps of gas extend from each galaxy, great halos of invisible material stretching outward. These halos reach across the darkness, almost touching, like two gentle giants reaching out to one another in the night. We drift through this faint, ethereal haze, so diffuse that billions of its atoms could pass through us without a trace. It is a gentle reminder that even in the deepest space, there are subtle connections, unseen tendrils of one galaxy brushing against the next. Slowly, steadily, the Andromeda Galaxy grows in our view. Once a distant smudge of light, it now unfurls before us as a magnificent pinwheel of stars. We see its central bulge glowing softly with the combined light of ancient suns packed closely together. Surrounding it, spiral arms wind outward, each arm a tapestry of young blue stars and silvery clouds of gas. These luminous clouds, vast nebulae, mark regions where new stars are being born, their faint glow adding gentle colour to the galaxy's spiral design. We continue our silent approach, drawn in by Andromeda's serene beauty. Around the galaxy's periphery, we notice a few small companion galaxies circling their parent. They are much smaller than Andromeda, mere satellites of stars caught in its gravitational embrace. Like fireflies orbiting a grand lantern, they accompany the larger galaxy on its journey. We pass one such companion, a modest elliptical haze, and it glimmers briefly in our mind's eye before we move beyond, toward the shining heart of Andromeda. Entering the outskirts of Andromeda feels like slipping into a vast stellar metropolis at night. The darkness of intergalactic space gives way to a gentle background glow as we find ourselves among the galaxy's outermost stars. Here at the galaxy's edge, a few solitary stars drift in quiet orbits, sentinels marking the border between the galaxy and the great void beyond. As we glide inward, these sparse stars grow more numerous. From a scattered sprinkle they swell into a glittering multitude, until they surround us like the distant lights of a city on the horizon. Deeper into the galaxy, the number of stars increases further. We pass near clusters of stars, globular clusters hanging like lanterns in the galactic halo, each containing hundreds of thousands of ancient suns gathered in dense, spherical swarms. These clusters orbit the galaxy's center, relics of an earlier epoch, and we quietly marvel at their concentrated glow. They are like floating jewels in the darkness, adorning Andromeda with a halo of sparkling points. Further inward still, the spiral arms become distinct rivers of light. We drift alongside one luminous arm, admiring the view. To one side, when we look up out of the galactic plane, the universe beyond reveals itself as a scattering of faint galaxies against the black. But our attention stays with the richness around us. Within the arm, stars of all colours and ages shine gently. Young blue-white stars, hot and brilliant, illuminate nearby clouds of gas with a subtle azure glow. Older, cooler stars with golden hues pepper the background. Here and there, a red giant star stands out like a ruby, nearing the end of its life and casting a warm light in its neighbourhood. We pass through a diffuse, glowing cloud, a nebula where new stars are quietly taking shape. Its gas is so tenuous that we traverse it without disturbance. Yet from afar, it paints the spiral arm with a faint pinkish hue. Inside these stellar nurseries, new suns will one day ignite, adding their light to the galaxy. The process is unhurried and calm, spanning millions of years, a quiet creation of brilliance in the vast night. Now the core of Andromeda draws near, a radiant hub of starlight at the galaxy's center. The brightness increases gradually as we approach, but it remains a gentle glow, not a blinding glare. Countless old stars crowd the core, their collective light merging into a soft, steady luminescence that blankets the central region. This galactic nucleus holds ancient secrets. Some of these stars have been shining for billions of years, perhaps since Andromeda's youth. Yet it is tranquil, a beacon of stability amid the swirling disk. At the very center, hidden deep within that brilliance, lies a supermassive black hole, a silent anchor around which the entire galaxy revolves. We cannot see it directly, but we sense its presence in the orderly motion of stars near the core, a cosmic still point in the galaxy's grand dance. For a moment, we linger in the calm near that galactic heart. All around us, stars are circling in immense, stately orbits. For these stars, a single journey around the core takes hundreds of millions of years. The movement is imperceptible on a human timescale. So here and now, everything appears serenely unchanging. The inner galaxy feels sheltered compared to the emptiness outside. Here, there is light, structure, and the faint whisper of cosmic activity. Yet even amid so many stars, the feeling remains one of profound peace. The stars do not rush or roar. They glide in silent harmony, like countless lanterns, following slow, graceful paths laid out by gravity's hand. As we soak in the gentle radiance of Andromeda's core, we might wonder if someone else is gazing up at these same stars from a planet within this distant galaxy, perhaps on some far-flung world orbiting one of these suns. Intelligent eyes look out and see our Milky Way as just a faint, hazy band in their night sky, an ethereal mist of light, much as Andromeda once appeared to us. In the quiet of this shared cosmic moment, across the unimaginable gulf of space, two galaxies behold one another. Each is home to beings who marvel at the other's faint glow, both connected by the silent darkness between them. In the far future, these two giant galaxies, Andromeda and the Milky Way, are destined to meet. Billions of years from now, they will begin to merge, their stars intermingling in a slow cosmic dance. Over immense timescales, they will form a single, larger galaxy, forever changing the night skies of whatever worlds circle within them. But all of that lies in a distant tomorrow. For now, in this cosmic present, the two galaxies simply drift peacefully, each a realm of uncountable stars, quietly shining in the dark. Eventually, our journey must continue. We bid farewell to the Andromeda Galaxy, leaving behind its tranquil spiral arms and brilliant core. As we drift outward through its outskirts, the stars thin out again. The soft glow fades as we pass beyond the last outlying clusters and lone stars. We watch Andromeda recede into the distance, its grand spiral shrinking to a luminous haze once more. Still beautiful, it hangs in the blackness like a distant whirl of light, growing smaller and fainter as we slip back into the depths of intergalactic space. Now we find ourselves once more in the vast space between galaxies. This time, we are even farther from home, not only far from the Milky Way, but now beyond Andromeda as well. We have left our local group of galaxies entirely, leaving behind that small family of galaxies that once surrounded us. That little cosmic community containing the Milky Way, Andromeda, the Triangulum Galaxy, and dozens of tiny dwarf galaxies, is now nothing more than a faint memory. Out here, in the intermediate reaches between galaxy clusters, the emptiness is even more profound. We are in a cosmic ocean of nearly perfect darkness and near total silence. Drifting in intergalactic space, we sense the true scale of the universe. The nearest galaxies lie millions of light years behind or ahead of us. Around us stretches a gulf so vast our minds can scarcely comprehend it, a void between great islands of matter. The darkness is not merely the absence of light, but almost a presence in itself, a velvety black that envelops everything. In this void, we experience a deep and tranquil solitude. Without a galaxy's nearby stars, the only illumination here comes from faint, far-off sources. The distant glow of galaxies and the soft background light left over from the cosmos's beginning. The starlight from those remote galaxies is exceedingly feeble, each one now just a tiny, muted glimmer, barely pricking the darkness. These lights are scattered sparsely across the cosmic sea, lonely beacons separated by unimaginable distances. They do not so much banish the darkness as adorn it with subtle points of beauty. In this immense emptiness, one could imagine stumbling upon a solitary star wandering between the galaxies, a rogue sun flung free from its home long ago. Such a lonely star would drift through the void with only its own faint light, perhaps accompanied by a handful of silent planets. It would shine like a tiny lighthouse in a lightless sea, an isolated beacon in the dark. But such sights are exceedingly rare. For the most part, this realm holds only the hush of emptiness and the faint glimmer of distant galaxies. We float weightlessly through this expanse, with no sense of up or down. There are no reference points here, no horizon, no ground or sky, only the endless night stretching in every direction. The silence is absolute. Our journey continues in utter quiet, accompanied only by the gentle music of our own thoughts. It is a meditative silence, ancient and unbroken, as though we have entered a sanctuary of the cosmos, where time itself slows to a soft heartbeat. Occasionally, a stray particle or a photon crosses our path, perhaps a wandering proton that has travelled for eons, or a lone particle of light from a star that exploded billions of years ago. These wayfarers are few and far between in the vast void, but they remind us that even here, in the great dark between galaxies, we remain connected to the rest of the universe. A single photon of starlight that finds us is like a greeting across time and space, a subtle assurance that we are not entirely alone in the emptiness. In this near-perfect vacuum, matter is so scarce that it can be measured in atoms per cubic meter. We might encounter just one solitary hydrogen atom in a volume of space the size of a small room, drifting quietly with no other atoms for thousands of kilometers around. It is hard to imagine a purer quiet or a greater isolation. And yet, far from feeling desolate, the effect is strangely comforting. The cosmos offers us this vast, dark cradle of stillness, a place where all the noise and hurry of our distant lives fades away, leaving only calm awareness. We become aware, too, of the subtle forces that pervade this emptiness. Invisible lines of gravity weave an enormous cosmic web, even here gently tugging on any object that drifts by, guiding the movements of galaxies and clusters over billions of years. Unseen, the gravitational influence of mass curves space imperceptibly all around us. We cannot see this web of gravity, but we can sense its presence, a faint underlying structure in the void, as if the darkness has a hidden framework known only to the universe. Indeed, the galaxies across the cosmos are arranged in a vast pattern, and we in this emptiness are floating within its delicate strands. If we could step back far enough, we would see that galaxies are not scattered randomly like isolated lights, but gathered into filaments and clusters with tremendous voids between them. We are currently adrift in one of those voids, a great cosmic gap between the congregations of galaxies. But ahead, a slight thickening of matter and a subtle tug of gravity hint that we may be nearing the edge of this void and drawing close to a region where galaxies cluster again. After a long sojourn in darkness, a subtle brightness appears in the distance. At first, it is just a faint, diffuse glow on the cosmic horizon. But as we glide closer, it resolves into a gathering of many soft lights, all concentrated in one patch of sky. We realize we are seeing not just one galaxy, but a multitude, a cluster of galaxies, luminous against the blackness of space. The sight is like coming upon a distant city after traveling through a moonless desert. Suddenly, where there was only emptiness and night, there are points of light and hints of structure. Gradually, the points of light grow clearer. We can distinguish individual galaxies now, dozens, or perhaps hundreds of them, all bound together in a gravitational community far larger than the little local group we left behind. This is a galactic cluster, one of the universe's grand gatherings of galaxies, a city of stars in the cosmos. As we venture nearer, the cluster's members shine with greater clarity, each a galaxy with its own shape and character. Spiral galaxies with graceful swirling arms, elliptical galaxies that glow with a steady, diffuse light, and many smaller irregular galaxies tucked among them. All are here, bound in a slow mutual dance like bees in an invisible hive. Entering this cluster feels like finding an oasis of light in the cosmic night. All around us are galaxies at varying distances, some relatively close by, others farther away, but still within the cluster's domain. The space between them, while vast, is much less empty than the barren gulfs we crossed before. Here, the typical distance between neighbouring galaxies might be only a few 100,000 light-years, far less than the millions of light-years that separated the Milky Way from Andromeda. In this rich environment, a galaxy's nearest neighbour is not so very far, and their proximity means they can gently interact over time. We drift slowly through the heart of this galactic cluster. The cluster itself has a gentle glow when seen from afar, the combined light of all its galaxies blending into a faint haze. Now, among them, we witness individual galactic forms gliding by like ships in a harbour at night. To our left, a spiral galaxy shows us its edge. We see it as a slender sliver of stars with a bright core, its spiral arms hidden from this side. To our right, another galaxy appears face on, revealing a whirl of stars and dust, slightly smaller than Andromeda, yet glittering with young star clusters in its disk. In the center of the cluster resides a giant elliptical galaxy, the elder of this galactic community. It is a massive, rounded congregation of stars, lacking the distinct spiral shape of a galaxy like our Milky Way. Instead, it glows with a soft, diffuse golden light, a sign that it contains mostly older stars. This elliptical is like a great ancient lantern at the cluster's core, around which the other galaxies slowly dance. Many of those surrounding galaxies may have formed from past collisions and mergers, drawn in over eons by the cluster's gravity and absorbed into the giants. This central galaxy itself could be the product of many smaller galaxies blending together long ago. Now it reigns in quiet splendor, its core housing an enormous black hole and a vast swarm of stars, all held in delicate balance. Scattered around, smaller galaxies accompany the giants. Some travel in groups or pairs, perhaps two spirals caught mid-dance, orbiting each other closely, or a tiny dwarf galaxy bravely circling a much larger neighbor. When galaxies in this cluster draw near one another, gravity's influence can gently distort their shapes. But all of this happens in extremely slow motion. Over tens of millions of years, one galaxy might drift through another, their stars mingling transiently without actually colliding, like two clouds passing through each other. Such encounters may spark new waves of star formation as gas clouds are compressed and lit with fresh starlight. In time, the two galaxies may settle into one, a graceful cosmic union played out over incomprehensible ages. Though dramatic on a galactic scale, from our serene vantage, it is just another part of the endless ebb and flow of the cosmos. Drifting through the cluster's core, we notice a faint background glow that suffuses the space between these galaxies. It is the cluster's intra-cluster medium, a tenuous gas heated to millions of degrees, filling the gaps between galaxies like an invisible atmosphere. We cannot see this hot plasma with our eyes, as it shines mostly in X-rays, but if we could, the entire cluster would be wrapped in a dim, ghostly aura. It is a reminder that even here, between the galaxies, there is matter linking them, a thin bridge that shares heat and energy across the cluster. To our sight, however, the cluster still appears as a collection of shimmering galaxies against the dark void, unaware of the hot, diffuse medium that bathes them. We continue onward, passing out of the cluster's densely populated heart. Behind us, the collection of galaxies begins to recede, their many lights blending back into a hazy patch. That cluster becomes an island of light in the distance, afloat in a sea of darkness. Around it, the universe stretches farther out, and we remain on our course, moving beyond this cluster to venture still deeper into the unknown. As we depart, we realize that this cluster was but one of many. Indeed, galaxies gather not only into clusters, but clusters themselves assemble into even larger conglomerates called superclusters, sprawling regions containing dozens of clusters and groups, spread over hundreds of millions of light years. Our own galaxy's home, the local group, resides on the outskirts of one such immense complex, which scientists have named Laniakea, meaning immeasurable heaven. And truly, it is immeasurable in its grandeur, a magnificent network of galaxies flowing together under gravity's influence, an enormous swath of the cosmic web. The cluster we explored here might be part of a similar supercluster far from our own, or perhaps it stands alone at the edge of a vast void. Either way, beyond it lies more of the cosmic tapestry to discover. Now, as we travel yet deeper into space, the grand pattern of the cosmic web emerges fully in our awareness. We have seen up close what a cluster of galaxies is like. Now we observe such clusters from afar as luminous nodes sprinkled through the darkness. Enormous filaments, unimaginably long chains of galaxies and dark matter, connect cluster to cluster, drawing a gossamer architecture across the universe. These filaments are sparsely populated with galaxies, forming bridges between the dense hubs. If we could step back and view billions of light years at once, the cosmos would appear like an immense lacework, or the foam on gentle waves, with bright threads and knots separated by great dark voids containing very little at all. We find ourselves crossing one of these enormous voids now, heading toward the next realm of light in the cosmic web. In the distance ahead, another faint congregation of glimmers appears, perhaps another cluster, or a group of clusters together, glowing softly at the edge of perception. Scattered in other directions, more such faint glows hint at the richness of the universe beyond our immediate sight. Every point of light we discern in these far reaches is not a single star, nor even a single galaxy, but often an entire cluster or supercluster of galaxies whose combined light is only just now reaching us. The scale of it is staggering, yet we float onward in calm acceptance, letting the immensity simply be, without overwhelming us. At this extraordinary vantage, we begin to sense the curvature of the universe itself. Space and time are intertwined, and looking out across these depths means also looking far back into time. The light from those distant clusters has been travelling towards us for billions of years, and we are witnessing them as they were ages ago. In effect, we see those clusters not as they are now, but as they were when their light first set out on its journey. Out here, distance and time blur together. The farther we roam, the older the light becomes that reaches our eyes. Pressing further outward, we chase the faintest smudges of light in the darkness, the very farthest objects we can possibly perceive. These mark the frontier of the observable universe. The galaxies and clusters at these horizons are almost unfathomably distant, so far away that their light has been in transit for nearly the entire age of the universe. We are, in a sense, time travelers now, using the universe's oldest light as our guide into the past. In the thin, dim glow of these far-off entities, we witness the universe in its youth. Galaxies here do not resemble the ones we saw closer to home. Many are smaller and less mature. We see them as they were perhaps 10 or 12 billion years ago, when they were still coming together. They appear as tiny, faint patches of light. Some are irregular in shape, like cosmic seedlings that have yet to fully form. A few shine as compact, bright blue blips, starburst galaxies, furiously birthing stars in their youthful vigor. Others are tinged a ruddy hue, their light stretched to longer wavelengths by the vast expansion of space during its journey to us. Indeed, the expansion of the universe becomes unmistakable at these distances. The space between us and those remote galaxies has been stretching all the while their light travelled, causing the light's wavelengths to lengthen, a phenomenon called redshift. To our eyes, this means the light reaching us now is fainter and shifted toward the red end of the spectrum, often pushed beyond the visible into the infrared or even radio waves. What little visible light remains from these distant galaxies is weak and ghostly. It is as if the light itself has grown tired from its long journey, arriving as a faded echo of its once brilliant self. And yet, even this fragile whisper of light carries a story, the story of those early galaxies and the dawn of cosmic history. We drift onward, pursuing the light of creation to the very limits of what we can observe. Each step farther is also a step further back in time. 12 billion years ago, 13 billion years ago. The universe grows younger as we travel outward. Galaxies become fewer and more primitive. The luminous web of matter, at least the portion of it we can see, thins out. We are approaching a boundary, not a physical wall, but a point beyond which the light has not yet reached us since the beginning of time. At last, we arrive at the edge of the observable universe. Here, roughly 46 billion light-years from where we started, we peer into a time when galaxies were just beginning to form, or had yet to form at all. The view becomes indistinct. Instead of individual galaxies, we find a pervasive faint glow. We have reached an epoch of the universe when it was filled with a brilliant, hot fog, the afterglow of the Big Bang, now cooled and spread thin over nearly 14 billion years of expansion. This faint glow is everywhere around us, coming from all directions. It is the cosmic microwave background, the fossil light from the dawn of the cosmos, originating when the universe was only a few 100,000 years old. This was long before the first stars or galaxies, when the cosmos itself was a searing, radiant cloud. Over the eons, that primordial light has cooled and dimmed. Today, we perceive it as a uniform, gentle whisper of warmth, only 2.7 degrees above absolute zero. Though feeble and invisible to our eyes, this glow is the all-encompassing backdrop of the universe, a lingering remnant of creation's early fire. It appears as a dim, diffuse haze, marking the ultimate limit of our vision. It is as though the universe has drawn a delicate veil here, beyond which no light from earlier times can reach us. Beyond this veil of ancient light lies the unobservable. The universe surely continues beyond the horizon of our sight, perhaps infinitely, or perhaps curving back on itself in ways difficult to imagine. But no light from those uncharted depths has yet arrived to reveal them, and so they remain hidden, a mystery just beyond our reach. Here, at the edge of the knowable cosmos, we stand as close as we can to the beginning of all things. It is a silent, almost sacred threshold, shimmering with the last faint afterglow of creation's dawn. We pause here, filled with awe at the vastness and majesty that surrounds us. From this cosmic shore, we reflect on the journey we have taken. We travelled from the gentle light of our Milky Way, across the quiet gulf to Andromeda, and then onward into deeper and deeper reaches of space. We crossed the great emptiness between galaxies and found sanctuary in a cluster of galaxies. We followed the filaments of the cosmic web and journeyed to the farthest clusters. And finally, we arrived at the very brink of the observable universe. It has been a voyage through both space and time, an odyssey spanning unimaginable distances and epochs, yet carried out within our imaginations with ease and tranquility. As we contemplate all we have seen, A profound peace washes over us. The sheer scale of creation humbles us, but it also reassures us. We are part of this grand tapestry. Our atoms were born in stars that lived and died in our galaxy, and those stars themselves were born from the primordial elements of the early universe. We have always been connected to this vast cosmos. Every particle of our bodies has travelled through the ages, forged in ancient stellar furnaces, scattered across space, and eventually gathered to form the Earth and us. In a very real way, we carry pieces of this entire cosmic journey within ourselves. Knowing this fills us with a gentle reverence. The lights of distant galaxies, the glow of nebulae, the silent voids, they are all our kin in existence. The universe is not cold and foreign. It is our extended home. When we look up at the stars, or when we imagine drifting among them as we have done, we are reconnecting with something fundamental in us. We feel the same stillness within that we found out there between the galaxies. We recognize the same light inside ourselves that shines in every star. Slowly, we become aware of the present moment again, bringing with us the tranquility of this cosmic journey. Back in the here and now, we can almost sense the gentle pull of Earth's gravity, the familiar presence of our own sun warming our world. Yet the calm perspective we have gained remains. We have touched the edge of infinity and felt the timeless peace of the universe. In the vast darkness, we found light. In emptiness, we found fullness. In the endless expanse, we found a sense of home. The cosmos has cradled us in its silence and grandeur, leaving us humbled and serene. As our journey through this galactic nightscape comes to a close, we carry that serenity within us. Under the eternal sky, we let our minds come to rest. The stars will continue to shine, and the galaxies will continue their slow dance, as they have for billions of years before us, and will for billions of years after. We are but brief travellers in this immense reality, yet our minds can roam its vastness and find wonder and peace there. Whenever we wish, we can close our eyes and remember this gentle voyage through endless night, recalling the soft glow of distant galaxies and the deep quiet between the stars. In this way, the calm of the cosmos stays with us. We end our journey not with sadness, but with fulfillment and unity. The universe has shared its grandeur and its silence, and we have listened. As we drift back to our ordinary world, we do so softly, carrying a piece of that starlight tranquility in our hearts. The darkness of space is no longer fearful. It has become a familiar friend, a refuge of contemplation. Finally, in the stillness that precedes sleep, or the gentle hush of dawn, we take one last look at the cosmic ocean in our mind's eye. We breathe in the boundless peace of that nightscape, and as we exhale, we let go of all remaining worries, feeling only the profound calm that the universe has instilled in us. In this moment, we are one with the stars, adrift in a sea of light and night, embraced by the quiet, mysterious beauty of all that is. We float in silence, and we are home,